My name is Gordon Slade, and I'm a professor at the University of British Columbia in the Mathematics Department in Vancouver, British Columbia, Canada. I received an email from Kodina Kotar, who I knew well because she was a postdoc in our department, in our probability group at UBC 20 years ago. And she told me about the program, and also that she, together with Tyler and others, were organizing a workshop on self-interacting processes, which is what I work on myself. Tyler also comes from UBC. He did his PhD there 10 years ago. So it's a familiar group of people to me and familiar subject, and I was delighted to be invited, and so I came for 1 month. Kodina proposed that she nominate me for a Clay to be the Clay lecturer, and so I was very happy that she did that and honored that the Clay Institute approved her proposal. The title of my talk is Self-Avoiding Walks, Spin Systems, and Renormalisation. And well, it's something that I've been interested in for decades now, and so it's about critical phenomena in these models, and in particular the statistics of self-avoiding walks. So a self-avoiding walk is just a path in a lattice which doesn't intersect itself. And surprisingly, there are many open problems about this model, even though it's so simple. And it has connections to combinatorics, to probability, to mathematical physics, and to polymer science as well. And the second item in the title is spin systems, so that's models of ferromagnetism, and I'm interested in particular in the critical behavior of those. And one thing I'll do is explain a sense in which the two models are the same. Self-avoiding walk and spin systems are the same thing if you look at it at the right perspective. And I'll use that in order to analyze the self-avoiding walk as a spin system, which I'll do using renormalisation. So renormalisation group is a textbook physics topic, which, however, is not so well developed within mathematics. And I won't be able to get into the technicalities of that in a talk like this, but I'll try to give a hint as to how the renormalisation can be used in order to compute critical exponents, particularly in 4 dimensions, for self-avoiding walk and spin systems. This is my 4th long visit to the Newton Institute. The first time that I came was in 1993. Before the math department was there, actually there were cows in a pasture outside the Institute in 1993. I came for 6 months, and it was a kind of a formative experience for me. I met many people with whom I continued to have and still do have contact and collaborations. And these programs at the Institute are extremely important, I think, for the research community generally. They forge new interactions between people, and people meet new people, and also it consolidates existing relationships. So this, research in mathematics is done very collaboratively these days, and this kind of program where people are brought together from all around the world is something which is extremely important in fostering that kind of activity and that research. So I'm very grateful to the Institute for providing that.